All right, in this video, we're going over the counting and stats pre-test. So make sure you get your formula sheet on you and your calculator. Our first question is a factorial. Now, since these are 1 mark, technically, you don't need to do the working out by hand, but I will show you both ways, just so that we know. 6 times 5 times 4 times 3 times 2 times 1. Definitely something I can't do in my head. If you wanted to do it on your calculator, it would be an option. So the option button's just there next to shift. Across, so F6 on the right arrow to probability on F3, and there's a little factorial button there. So 6 factorial, done. So 720. Or, you could type in all that on your calculator and you'll get 720. Now, by hand, this one, 15 factorial over 13 factorial, looks horrible, isn't too bad. So this is 15 times 14 times 13 times 12 times, and then all the way down to 1. And this is all over 13 times 12 all the way down to 1. Okay, so with this one here, you're going to cross off the 13 down to 1 on the top and the bottom, because they sort of cancel, and you're left with 15 times 14, which is whatever that is. Again, can't do that one in my head. 15 times 14 is 210, and that's the answer. Now, if you wanted to do it on your calculator, you could go 15 factorial over 14 factorial. Again, because these questions are just 1 mark, you can do it on your calculator if you want, but I'd recommend practicing it by hand. Sorry, that should have been 13 factorial on the bottom. And again, good to double check your answers, otherwise you might have got something wrong. C10-4. So the CNR formula, so you get the 10 factorial on the top, and you get the 4 factorial on the bottom, and you get 10 take 4 factorial along with that on the bottom. If you want a quick way to double check you've done that right, the 2 bottom numbers should add up to the top number. So we get 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And we get 4, 3, 2, 1 with the 4 factorial and 6 times 5 times 4, 3, 2, and 1. Okay, again, we're going to get some stuff cancelling, so all that will cancel off with all that. We can go 4 and 2 cancel with the 8, and 3 sort of cancels with the 9, but you divide it out, so you got 3 left. So all that gives us is 10 times 3 times 7. Now this is just a coincidence, but it's also 210. Now, if you want to do this on the calculator, you go 10. Now remember that options button there next to shift, and in probability you've got NCR, so 10C4 should give you 210. This one here is just different notation, so this is C97. So I'll just double check what the answer should be on the calculator before we do it, so 36. And if you step this out, pretty much what you get is 9 factorial over 7 factorial times 2 factorial. So that's 9, 8, 7, 6, all the way down to 1. And then it's 7 and 6 all the way down to 1 times 2 factorial. So 2 times 1. So you can pretty much just cancel off 7 down to 1. And then you've got 9 times 8 over 2. So the 2 might cancel off with 8 and leave us with 4. So all you get is 9 times 4, which is 36. And again, you can do it on your calculator if you want. And also there's the NCR formula on your formula sheet there. There. Okay. Next, how many different 3-digit numbers can you make? And you're not allowed to use repeat numbers. So with this one, I've got 3 spots, and I've got 1, 2, 3, 4, 5 numbers to choose from, and we're not allowed to reuse them. So there's 5 choices here. We've used up a number, so now there's 4 choices there because we've used one. And now there's 3 choices here. Okay, so 5, 4, and 3 is what we need to work out. And that is going to give us 60. So 60 ways. If you have time in the test, you could actually list out all 60 just to make sure you got that right. It'll take you ages, so I'd wait till the end to do it. How many different 3-digit numbers can you make if the number has to be even? So we sort of go like this, and we've got to have pretty much just a 4 at the end. So this must be a 4, because if it's a 1, 3, 5, or 9, that would be an odd number. So this has one way to work it out. I'm going to move right to left in this one. So I've used up one of my 5 numbers. I now have 4 numbers left. And then I've used up one of those, so I now have 3 numbers left. So it's 12 ways to do this. Okay. If you want, there's sort of another way you can think about it. You can do 60 times. Every 1 in 5 of these numbers are even. So you can do sort of 60 times 1 over 5 should give you 12. So generally this way on the left is a little bit better, but this is a way to check that you've got the right answer. Okay, the number has to be greater than 340. So that's a 3-digit number. We could have 4, 5, or 9 here. So there are 3 choices. I've used up one of my 5 numbers, so there's now 4 choices left. And then there's 3 choices left. The other thing that could happen is I could have a 3 here. So there's 1 choice for that. And then this one, because it has to be greater than 340, I'd have to have a 4, 5, or 9 here, because that number would need to be bigger than 4. So there's 3 choices there. And let's see. So I've used up 2 out of 5, so there's still 3 choices left for the last one there. So this would be 9 here, and this would be 9 lots of 4, so 36. And then we add them up, so total is 36 plus 9, so that is 45. I'd also really encourage you to look and see out of your 60 ways, can you find the 15 that are smaller than 340? See if you could do that. Okay, how many possible paths are there from A to B if you must keep traveling to the right? So pretty much what we do here is we go up the top path. There are 3 ways to do that. And then there are 2 ways to do that. And then here there are 2 times 3, which is 6. And then we sort of add these numbers. So 3 plus 2 plus 6. And we can just call this like number of ways. I might write the 6 in as 2 times 3. So it's 3 plus 2 plus 6, which is 11. 11 ways to do this. And again, if you want, and if you have time at the end of the test, you could see if you could draw out all 11 ways. Okay. Next, we've got these teachers who are joining like a quiz team. How many possible teams of 6 can be made from these 9 people? That is C9, 6. 9 people, 6 choices. And I'm not asking you to show your working, so I can just go 9C6. So there's 84 possibilities. Okay. Now, if it needs 3 English teachers and 3 maths teachers. So this is a team of 6. 1, 2, 3, 4, 5, 6. Now, whenever you make a team like this, there's no order in the team. There's sort of just 6 people thrown in together. So it doesn't matter what order. I'm going to put the English teachers first, and then I'm going to put the maths teachers. Okay. Now, C, English teachers, so there was 1, 2, 3, 4 of them. So we're just going to do that. So 4 English teachers. And there are 3 spots to choose from. And then for maths teachers, there are more maths teachers because maths is a little bit better. C5, 3. Okay. Now, 4 NCR 3 would be the first bit. Might work out what each bit is. So this is 4 times, and then 5 NCR 3. You technically don't need the brackets here, which is 10. So this is 40 ways. Okay. Next, you need at least 2 English and at least 2 maths teachers. So we could look at the team which is 2 English and 4 maths teachers. We could look at the team which is 3 English and 3 maths teachers. And then we could look the other way around. So we could also look at 4 English and 2 maths teachers. Okay. 2 English, 4 maths. So we've got 2 spots for, we'll put the English first again. And we've got 4 spots for the maths teachers. That's an M there. All right. So how many English teachers were there? There were 4. So this one here is going to be C4, 2. 4 people, 2 spots. And there were 5 maths teachers. So C5, 4. And then what we can do is we can just go 4C2 and then times it by 5C4. 5C4. So that's going to give us 30 ways. Now, this is 3 English teachers and 3 maths teachers. So this is actually the same as the one we did before, C4-3 and C5-3, which is 40 ways. And then we've got 4 English and 2 maths teachers. So 1, 2, 3, 4 English teachers and 2 maths teachers. So this is C4-4 and C5-2. And we can work that out. So 4C4 and 5C2. Okay, so that's 10 ways. Okay, so the total is 30 plus 40 plus 10, which is 80 ways. Cool. All right. Now, there's one other thing that you can do to sort of check. What are the 4 possibilities that aren't included here? So a much easier way to do this question is we are missing. Now, you can't go any further down this way because if you try and do 5 English teachers, you're out of English teachers. And then you would have 1 maths teacher there. But you can sort of go back further up this way. We could look at, let's see, 2 English, 2 maths teachers. So the one that we're not including is the one where we have 1 English teacher and 5 maths teachers. The reason we didn't include it is because it didn't have this, like at least 2 and 2. But if we work it out right, this should be the 4 that we're missing out of the 84. So this would be C41 for the English teacher. And if we're going for maths teachers here, this should be C, there were 5 maths teachers and 4 spots. So let's see what we get. 4 NCR1 times, and then we're looking at 5 NCR4. And then hopefully my apologies, that should be 5 NCR5. You can see here the process. I noticed I was expecting 4 and I didn't get it, so I've obviously made an error somewhere. 5 NCR because there were 5 spots there. I should have drawn a little 5th spot for maths. Okay, and if we do that, it is hopefully 4. Syntax error, lovely. 4, yeah. So you can see that these are the 4 that we're missing in this question out of the 84, and that's why there are 80 ways in total to do it. So please double check your answers like that. Okay, Pascal's triangle. So we do this by chucking 1s along all the outsides. Now 1 and 3 up there give us 4. 3 and 3 give us 6. 3 and 1 give us 4. 1 and 4 give us 5, 10, 10, 5. And that's Pascal's done. The 20th row starts as this. Now, when you deal with Pascal's triangle, something like this 6 here would be C, and then it's the 4th row, and it's the 3rd, well, technically 2nd spot, because you start counting from 0. So this would be like C4, 0, and then C4, 1 there. And if you work out C4, 2, you should get 6. Now, I'd really, really encourage you to do this in the test, just to make sure that you've got the right idea of how the C's line up to the Pascal's triangle. So they're telling us, oh, by the way, with all this, you count this first one as row 0 and row 1 and etc. You always count from 0. So the 20th row starts as that. So if we've got it right, this should be C20, this should be C21, and this should be C22. And then the next number would be C23. Okay, let's actually see if this works. This is why I put the examples in the question, just to make sure that you can check that you're doing it right before you commit to your final answer. So 20C1 should be 20, and 20C2 should be 190, which it is, so that's good. and then 20c of 3 should be our final answer, 1140. Okay. Use Pascal's triangle to expand that. So you may even, it's not directly on your formula sheet, but the binomial expansion is. So you can see the powers of A go down, the powers of B go up, and then the coefficients are the C's. So A plus B to the 4 is, so it's A4, A cubed, A squared, A, and then it's gone. The B's will go up, so B squared, B cubed, and B to the 4. And then the coefficients come from Pascal's triangle. So this would be a 1, and then the row in Pascal's triangle is 4, 6, 4, and then 1. So I'm reading off just that row there, the 4th row. You know if you got the row right or not, because otherwise you'll have too many coefficients or not enough. You might also notice that if you look at the powers on A and B, these should always add up to 4. So 2 and 2, for example, add up to 4. 1 and 3 add up to 4. Nothing and 4 add up to 4. So make sure that happens. That's because it's to the power of 4. It'd be a different number otherwise. And then really we don't need these 1s here. So you can get rid of the 1s there. Might not be a bad idea to have on your cheat sheet the first few, so maybe 2, 3, and 4, maybe even 5 as an expansion, just so that you can save yourself time in the test. 3x take 4, all to the power of 4. So this would be 3x to the power of 4. This is a to the 4 done. And just to be really clear, a is 3x and b is 4. Now, you can think of it like b is minus 4, and that will work out nicely. But if you ever see a minus, all you have to do is go plus, minus, plus, minus, plus, and then just like flip them. Okay. Next term would be 4 lots of a cubed, so that's 3x cubed, and b, which is 4. Then it's a plus. So this would be 6 lots of 3x squared and 4 squared. Then we have a minus. It's 4 lots of 3x, and then it's 4 cubed. And then it is plus, because we've just had a minus, b to the 4. So this is 4 all to the power of 4. I've actually made a mistake on this line. I'd recommend that you pause the video and see if you can spot it. Hopefully you've done that. This 2, I want to square the entirety of 3x. So it should be outside the brackets. Okay. Now we need to square we need to raise the 3 to the power of 4 and the x to the power of 4. So this becomes 81 x to the 4. Now, I want to do all the numbers here. So I've got a 4. I've got a 3 cubed. And then I've got another 4. So that's 432. And I've still got an x cubed in that term. 6. I've got 3 squared. And I've got 4 squared. So that's 864. Here I've got 4 and 3 and 4 cubed. So 4 times 3 and 4 cubed. So that's 768. Okay. And then 4 to the power of 4. So you don't really need the brackets, but 4 to the power of 4 is 256. Okay, and that is a full expansion. I'm actually going to show you a very cheeky trick to check that you got this right. So we'll just delete out any graphs we have. So what we could do is we could graph 3x take 4 to the power of 4. Let's just get an idea of what that graph looks like. So this sort of happy face shape. I might just set the window back to standard so we can see the whole thing, but there it is. And I'm going to graph also what we just got. So that would be 81x to the power of 4, 432 x to the power of 3, 864x squared. By the way, if you do this right, your powers of x should drop. 768x plus 256. And we're going to draw that, and then the graph should go on top of each other. You saw the blue draw first and then the red draw. And if you want to check that, you can turn the graphs on and off by doing select. You'll see the equals sign turning on and off. So if I turn off that red one, I get the blue, for example. Okay. People getting their P's. So we should check that we're doing the frequency table right. So apparently there's 5 18s. Let's see if we can find them. 1, 2, 3, 4, 5. So that is good. This is just to make sure that you're actually doing the right thing. There were no 24s and there's supposed to be 125. Yep, so that's good. Now we can sort of do the rest. So with 17s, there were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. With 19s, I think there was 1 and then 2. 22, there were 1 of those. So we'll just look at 22 there. And the rest should be 0 because I think I've crossed off all my numbers now. Okay. Really quick check that we've got the frequency table right. If I do 11 plus 5 plus 2 plus 1 plus 1, that's all the numbers, so I should see 20. And the list, you could count 20, but also the question says there are 20 people. So we know we've got them all. Okay, let's put this frequency list in. So there's sort of 2 ways you can do this. You can do the big long list. That's going to be longer. Or you can do the frequency list. So I'm going to pop the frequency list. And then we've got 11, 5, 2. Okay, so that's a frequency list in here. We're going to go calc. Now, before we do this, we're going to go set. Usually your calculator will be set up like this. If you have a 1 here, that means you're entering a big long list like at the start of the question, which you can do. But we've got a frequency table. We've got 2 lists. So I have to set list at F2. And then list number 2 is the frequency numbers. Now I can exit out, and now I can hit 1 bar stats. So actually, I've skipped a question. This is for part C. But let's just do that first. So the mean is the first number, so that's 18.1. The minimum, I think your calculator does tell you, but it's 17. The Q1 is 17. Median is 17. Q3 is 18. The max was 25. And we need to figure out which standard deviation we're using. So they want to investigate the age of people in SA applying for their Ps, and they've only surveyed 20 people. I think there are more than 20 people in South Australia, so we have a sample standard deviation. So remember, that is for population and that is for sample, and your calculator gives you both. So we need to take the bottom one where it says SX rather than sigma X, 2.02. So make sure you got that sample. Okay. I guess these have like X's on the calculator. Now let's go back to the one I missed. The mode, your calculator actually does tell you the mode is 17 years old. And if we look at the mode on the calculator, it should say mod is 17. Because many people get their Ps as early as possible. The reason you've got such a spike at 17 is because a lot of people just get them as soon as they can. So when they're 17 years old. Okay, would it be reasonable to assume that it is normally distributed? No. So the P's data, if you look at like 17 years old through to 25 years old, sort of looks like this. It's got a huge spike and then not many people getting them later on. And then this would be like your frequency, but a normal distribution should look like a bell curve. So no, it is not bell-shaped. And you could even say that the data is positively skewed. I always feel like skew is backwards than what it should be. It always feels like that should be negative. But think of it like you're taking a bell curve and you're pulling the positive side, so you're grabbing this tail and like pulling it out that way, you would end up getting like a curve like that, which is the positive skewer. So that's how that one works. Okay. Last year's methods exam, so this is a normal distribution question. So we need some notation first. So let X be the mark of a student on the methods exam. And we got to give the units, so that's percentage. And then we say X squiggle N, and then we give the mean and standard deviation. So 72 and 10. Okay, so that's the first bit of notation. You absolutely need that. And then calculate the probability that they receive between 72 and 82. So the probability that 72 is less than X and less than 82 roughly equals. So you go into stats, you go into, exit out of all this, you go distribution on F5, normal and NCD. Your lower is 72, your upper is 82. Your standard deviation would be 10, and your mean is 72 as well. So we're just going to go execute 0.341. That is all you need. No more notation. You don't need to write in what you did for your calculator, but if you want it like on a cheat sheet or something, then you can take those 4 numbers. That is the probability of 0.341. If they ask for a percent, it would be like 34.1, but they're not actually asking for that. So just be aware of the difference in those two. Now that we've done this notation, so this was 1 out of 2 marks, and then this bit was the other 1 out of 2. You'll notice the next question's only 1 mark, and that's because you don't need to do the notation again. We've already defined X. So probability that X is greater than or equal to 50. So again, it's normal CDF. You're going to set your lower to 50 and your upper to 9999999. You want to go as high as possible. Essentially, you'd want to set it to infinity, but there's no infinity button on your calculator. 0.986 is the answer there. Okay, a student who achieves in the top 5% of the class gets a merit award. So really what we're after is this mystery mark, and we'd like only 5% of students to be to the right of that, which is a probability of 0.05. Okay, so this is going to be an inverse normal question. So distribution on F5. Going to go normal, and then F3 for inverse. So we're going to do a right tail because I've shaded into the right. We're trying to do better than this student, and 0.05, and then keep the same mean and standard deviation. We're going to execute that. 88.4. 88.4% needed. Okay. Now, let's see. So if we go back into normal CDF, so distribution normal NCD, I should be able to set my lower as 88.4 and my upper is a whole bunch of 9s. If I do this, I'll get 0.05, which I do for the probability. Okay, now this one's a little bit funky. So you got your physics exam as well, and you're trying to figure out which 2 grades are more impressive. I know some people have looked into z-scores. That's the formal way to answer this question, but that's technically not learned until year 12. So we're going to have to calculate some probabilities. So we're going to look at methods and physics. Okay. So probability that we do better than them on methods. So they got 80% on their methods exam. So probability that X is greater than 80 roughly equals, and we can see that. So if we go back here and change that to 80, and then execute, there we go, 0.212. And for physics, we actually need a different variable. So let y be the mark of a student on physics exam in percent. I was trying to squeeze that onto one line, did not work. Y is distributed normally. The physics exam has a mean of 78 and a standard deviation of 12. Okay, so probability that y is greater than, and they got 85, roughly equals, and then we can just do a normal CDF to work that out. So the lower has got to be 85, and then the upper has to be the same. The standard deviation here is 12 and the mean is 78, so it's different. Okay, the probability is 0.279 or 280. So the way that we can interpret this is we can say something like there's a 21% chance of beating this student on methods and a 28% chance of beating them on physics, so doing better than them. So the methods grade is more impressive. It's less likely for you to do better than them on methods, so that means that their methods grade was better. Cool. So I want to point out as well, even though their methods exam was less, like percentage-wise, it was only 80 versus 85, compared to the averages and the standard deviations, and grade of 80 on methods was considered better. Okay. Again, if you like, you can go z-scores. But this is not till year 12, at least not formally till year 12. I know some people have looked at it. Okay. Now, a person rolls 2 6-sided dice. We want to calculate the total number of possibilities. So basically, you've got this. An order does matter here. So there are 6 choices for the first one and 6 choices for the second one. Because, you know, like, if you roll a 4 on your first dice, you can still roll a 4 on the second dice. Like, you haven't used up that 4. So there's 36. Now, here we go. Number of ways. So to roll a 2, there's one way to do it. So you can get a 1 and a 1. To roll a 3, I can get a 1 and a 2. Or I can get a 2 and a 1. So that's why there are 2 ways to do that. To roll a 4, it's 1, 3, 2, 2, and 3, 1. Okay, you might be able to guess that it just sort of goes up to 4. But let's check. So if I want to roll a 5, I could go, let's see, 1 and 4. I could go 2 and 3. I could go 3 and 2. And I could go 4 and 1. So yes, there's 4 ways to do that. If I want to roll a 6, I could roll a 1 and a 5, 2 and 4, 3 and a 3, 4 and a 2, and then a 5 and a 1. So there are 5 ways to do that. If I want to roll a 7, I could go 1 and a 6, 2 and a 5. I could go for a 3 and a 4. I could go 4, 3. I could go 5, 2, and I could go 6, 1. And that is 6 ways to do it. Something very funny happens with 8. So with 8, I can't roll a 1 on the first dice because you can't roll a 7 on the second dice. So I would have to roll a 2 with a 6, a 3 with a 5, a 4 with a 4, a 5 with a 3, or a 6 with a 2. Not put commas there. So there's actually less. There's actually 5 ways to do it. Now, if you map out the rest, it just goes 4, 3, 2, 1. And you can quickly check. So 12, you have to roll a 6 with a 6. There's only one way to do it. Okay, next we're going to calculate the probabilities. So the reason that I've put the probability table in and started it is so that you can check. If I work out 1 out of 36, I should get 0.0278. If I work out 2 out of 36, I should get that number. 3 out of 36, I should get that number. 4 out of 36 gives me the next number, 0.1111. 5 out of 36, 0.1389. 6 out of 36, 0.1667. Because this table is symmetric, 0.1389, 0.1111, 0.0833, 0.0556, and 0.0278. So you should notice it being quite symmetric there. Okay. Calculate the mean and standard deviation. So there's sort of two approaches that you can take for this. So one way that you can do it is we can look, so stats, we'll clear out the whole table. Absolutely. The first one has to be the left column. And then the second one you can sort of choose. So I could go we can see what happens here. So calc, you want to set it to a frequency list, one var stats. That will spit out a mean and standard deviation. If you want, you could also set the probability. So you go 1 out of 36, 2 out of 36. If you do that, you should also get that. Interestingly, you'll notice you don't get a sample standard deviation, and that should clue you in. This is not a sample, this is everything that can happen. So we're actually using population standard deviation. So here, the little mu symbol for mean, this was X bar up the top. So this is 7. And the standard deviation should be the same regardless, 2.42. And that was the same mean as standard deviation I got before. Okay, using normal distributions, calculate the probability of getting a sum between 5 and 8. So now that we've got this, we can actually model this using a normal distribution. So let X be the total sum when 2 dice are rolled. X is distributed normally, 7 and 2.42. We've got a mean and a standard deviation. So the probability that, so we're between 5 and 8, so we want 4.5 and 8.5. The reason you put the extra 0.5 is just because of rounding. Like you can, like something like rolling a 4.7, although you can't do it, the way you would interpret that is you'd round up to 5. So let's go into a normal CDF. So we're going to go into stats, exit back out, dist, norm, and CD. 4.5 is your lower, 8.5 is your upper. Your standard deviation was 2.42, and then your mean was 7. I really should use the full unrounded version of the standard deviation. 0.582. Okay. Actually, we'll see if that changes at all if I use the full unrounded version, just so I can be extra proper. So the full version was 2.415222945. I know it probably doesn't seem like a big deal, but sometimes when you use like rounded versions of stuff, little changes can blow up to very big differences in the final answer. Like if you square numbers, for example, small numbers get really big. 0.582. So it is similar, but it is very possible the probability could have been slightly off had I not used a rounded version. Okay, there we go. So that's it. They're asking for what a probability, so that's literally all it is. Calculate the probability actually using the table. So we want between 5 and 8. So I want to add these numbers here. So the numbers that I'm after are, what I might do is the probability that 5 is less than X is less than 8 equals the probability that we're equal to 5, the probability that we're equal to 6, the probability that we're equal to 7, and the probability that we're equal to 8. Okay. So I'm going to put roughly equal. Actually, I'm going to put exactly equal to this. These probability, no, I'll just do the decimals. So 0.1389. What's the first one? So we'll do a rough equals. I was going to go like the 5/36 version or something, but we'll just use the decimals. 0.1667. probability that x is 7 was, oh, sorry, I'm off by 1. 1, 3, 8, 9, 1, 6, 6, 7. So that should have a 0.1111 at the start. And then we've got to go, where was it? Probability that we equal 8, so that's 0.1389 again. And we'll see what that gives us. Okay, so 0.1389 plus 0.1667 plus 0.1389 gives us 0.5556. Beautiful. So that is the probability. And you might notice that this actually pretty closely matches what the probability guess was from the normal distribution. If you look at this distribution as like a table, it's not bell-shaped, but it sort of does look like this. So it's more like triangular. Fun fact, if you roll 3 dice, it becomes more bell-shaped. If you roll 4, it becomes even more bell-shaped. And then this normal distribution would get closer and closer. So if the question was, why don't these perfectly match? The answer would be because it's not perfectly bell-shaped. But they're actually pretty close. And that's going to be it.